Drew.
How you doing, Professor?
Good. How are you?
Pretty good. Are you a big gamer?
Not as big as I used to, but I am. I know PS5 is coming out soon.
Oh, I got one this morning, luckily.
Nice. Did you wait in line or did you order ahead of time?
I ordered it off of Best Buy when it dropped at 6 a.m.
Nice.
Yeah, pretty cool.
What have you tried on it so far?
Well, I have to wait till it comes in on Monday.
Oh, okay.
Yeah, that made me wait. But I bought some games for it already.
Nice.
The new 2K and Madden and Spider-Man.
Nice. Is it the same studio that did because there was a really big Spider game that came out, but Spider-Man game last year. Forgot the studio who did it, but it was really good. I remember I watched my friend play it a lot.
Yeah, it's like the sequel to it. So I had that one too. It's pretty cool.
Oh, nice. Oh yeah, this one is Miles Morales, right?
Yeah.
Okay, yeah, I remember seeing the trailers for that. That looked pretty good. Okay, it's 1 o'clock, so let's go ahead and get started today. All right, good afternoon, everybody. How's everybody doing today?
Pretty good.
Good, good. Yeah, hopefully everyone enjoyed their holiday yesterday, holiday in the middle of the week. It was a little bit strange, but it's you know, always a welcome time to get a day off. So I haven't finished grading your guys' exams yet, so I'm still working on that. So I'm hoping to finish that by this evening. So hopefully by the end of the day you'll know what you got on your exam. So unfortunately I'm only about a quarter of the way done right now, just because yesterday there was some personal matters I had to attend to, but so I'm a little bit behind on that. But I'm hoping to finish grading that by this evening, so you'll know what you got in your return. Okay. Okay, so the plan for today is that we're going to continue along, you know, talking about risk in engineering. Okay, so today we're going to dive a little bit deeper and define, you know, talk about what's like called an acceptable level of risk and how different groups of people view risk, mostly the public and government regulators, and see how that, you know, how that affects your work as an engineer. Okay. But before we get started, are there any questions on anything before we get started today? Okay, so if there's no questions, let's go ahead and jump right in. Okay, so last time, you know, we talked about kind of the concepts of risk and safety as they pertain to engineering projects. So, you know, we talked about how, you know, it's the engineer's first and foremost duty to protect the safety of the public or the people that consume their project. Okay, and so, you know, we're gonna stay on that topic, and so today we're gonna dive a little bit deeper. Okay. And so remember from last time what we talked about as, you know, as an engineer, it's impossible to eliminate all risk from a situation. And so it's not your responsibility to prevent, all bad things from happening, right? And so if you make pencils, you shouldn't feel bad when John Wick kills someone with the pencil, right? That's more a problem with John Wick than it is with the pencils themselves. Okay? And so as engineers, when we design our products, it's not a goal to have to take that risk percentage and get it down to zero, because that's literally going to be impossible. And so what's a more realistic goal is to determine what is an acceptable level of risk given a certain situation. Okay. And so, if you kind of already accept the fact that no matter what you do, you're going to assume some risk, we have to kind of quantify and say, what is the acceptable level of risk for, for engaging in activity or designing a product? And of course, the thresholds for acceptable risk are going to be different, depending on, what field that you're working in, what kind of product that you work on, right? Because some activities and some products are going to be inherently more risky than other ones, right? And so, designing a pencil, probably doesn't carry as much risk as, designing an airplane. Right? So an airplane, there's, a lot of other things that can go wrong, rather than someone just kind of picking up a pencil and writing. Right? And so what we're going to talk about today are kind of two different frameworks in which you can kind of approach this idea of acceptable risk. And then we're going to also talk about, how do other people perceive acceptable risk? Because it's, we have our own definition of acceptable risk as engineers, just because we're privy to all the technical details, and a lot of the things that can go wrong. But a lot of times it's not only about how we perceive risk and how we perceive certain situations, but how we get how other people perceive them as well. And so we'll talk about how public perception can affect things, and how government regulators can and how their views of risk can affect things as well. Okay, but first thing I want to do is I want to bring back one concept or one school of thought that we talked about at the very beginning, which was utilitarianism, and how that applies to risk. Okay. And so just to kind of jog your memories, utilitarianism is kind of a school of thought where their main goal is to maximize the well-being of society as a whole. Okay. And oftentimes this what they deem as acceptable is that this kind of comes at the cost of the well-being of a small number of individuals. Okay. Okay. And so, because of this, utilitarianism kind of already just kind of in its central, just in its central definition, it just accepts that there must be some risks and some sacrifices that must be made to achieve this goal. Okay. And so from that, we can we can come up with a definition of acceptable risk through the lens of utilitarianism. Okay? And so according to utilitarianism, an acceptable risk is one in which the product of the probability and magnitude of harm. Okay? Okay. And so this will be kind of unique because it kind of almost has like a formula to it, although it's how you define these terms is up for debate. But I'll give you kind of the formula for it. Right? Right? And so the formula form is that the first part is we take the probability of harm. I can spell it correctly. And we multiply that by the magnitude of the harm of the harm. Okay. If this is less than or equal to the probability of the benefit and the magnitude of the benefit. Okay. And the magnitude of the benefit. Okay. If this formula is satisfied here, then this is what's deemed as an acceptable risk. Okay. And so basically, you know, it's kind of a very kind of a numbers way to approach this, where you say, you know, what's the chance that something bad is going to happen, and how bad is that going to be, and then we compare that to what's the chance that something good is going to happen, and you know, what's the magnitude of that good thing happening. If there's more benefits than there are harms, then you know, this is deemed as an acceptable level of risk. And so it's very kind of like, it's almost like a robot's approach to making engineering decisions. So they try to put numbers on this, you know, and they you know, quantify as much as they can. Okay. And of course, you know, if you increase the amount of people that benefit from your actions, and so you know, basically the more people that are affected by this, then this quantity on the right, on the bottom right here, the magnitude of the benefit, this goes up with, you know, the more people that you touch. So that very much goes along with the ideas of utilitarianism, of, you know, trying to benefit as much as possible. Okay, so obviously, you know, this is, you know, it's one way of looking at it, but it's controversial, right? And so because what this requires is that you basically put a number on basically every quantity in this expression here. So I think, you know, quantifying probability is, you know, it's, I think for a lot of times it can be difficult, but at least it can be done, and not as controversial. But then quantifying, you know, how much harm that someone does to something, or how much good it does to someone, you know, that's something that can be really, you know, difficult. And also, so I'll tell you, you know, when this has been used in the past, things that people or ways of thinking that people have used to justify this is that, you know, in terms of like the magnitude of harm, you know, they might put a number and saying, like, you know, this will harm X amount of people, or this will result in, you know, X amount of money in lawsuits or reparations, right? You know, that's one way to do it. Or, you know, cost of medical, right? And so if you have to pay for the medical for someone, then, you know, that's one way to do it. But, you know, of course, these are all, you know, up for debate, of course. And then for the benefits, you know, it's, you know, there's always, you can always quantify the economic benefits for something like, you know, getting more people to work or something like that, or improving their productivity. Or you can quantify things in, you know, the medical bills that they don't have to pay. So there's a lot of, you know, things that are up for interpretation for this. And so it's not a hard and fast rule, because there's so many different ways that you can quantify, you know, magnitude of harm or magnitude of benefit. But it's at least one starting point, I think. And so that's kind of why I bring it up in this class, where, you know, it's not an end all be all, you know, definition for acceptable risk, but at least get you in the ballpark. And so, you know, if there are some things where, you know, if you know, use this formula and you say that, oh, the benefits are going to way outweigh the potential harms, then that's one way that you can justify it. Or if the harms way outweigh the possible benefits, then this would be another reason to you know, to not do a decision. But whenever things are kind of close, or, you know, if you're having trouble quantifying these things, then you might want to look at some other ways to quantify acceptable risk. Okay, are there any questions on this? Okay. All right, so that's one way to define acceptable risk. And so another way that we can define it is in terms of what's called the capabilities approach. Okay. And so this kind of frame of thinking focuses more on the capabilities of the individuals involved. Right? And so, you know, this contrasts a lot with the previous one, because you know, traditionally in like the utilitarianism point of view, when you talk about risk and harm, you know, they're usually put in terms of things that are very easily quantifiable, like economic losses or loss of life. Okay? But there's a lot of ways that, you know, that engineering product can affect people's lives that can't easily be quantified by things like that. Okay. And so, you know, the idea behind this capabilities approach is trying to see, you know, how do our engineering products affect how people live their lives. Okay. And so let's define capabilities especially like that. Okay. And so the definition for capabilities is, you know, the ability for people to live the kind of life that they find valuable. Okay. Okay. And so this, you can see, you know, this definition of capabilities goes beyond like the traditional definitions of just, you know, economic status or loss of life. Okay? And so if we kind of redefine our definition of risks as the probability that an individual's capabilities might be reduced, then, you know, we can kind of start thinking about risk and, you know, what's acceptable in a different ways. Okay? And so, you know, how do we, you know, even though this is, you know, we say that this might be harder to quantify, you know, we still need some indicators for us to know, you know, how are people's capabilities being harmed. Okay. And so for an example, let's consider, you know, the capability for someone to exercise. Okay. This capability by itself, you know, might not be easily quantifiable, right? But we can look at some indicators, you know, either, you know, from this person themselves or just, you know, in the environment around them that kind of indicate their capability to do so. Okay. And so one possible indicator for this would be like, you know, easy access to parks and gyms. Okay. Okay. And so if a person, you know, has access to these kinds of facilities, then we can say that, you know, they have a reasonable capability to exercise. Okay. And so if, you know, you as an engineer, you know, you work on, you know, a public project, say like you're working on the roads or something, right? So you're you know, either designing new roads or you're you know, fixing up the roads in a certain area. Okay. And so if this impacts a person's ability to access parks or gyms, then we can say, you know, this is going to impact their capability to exercise, and this is a risk that, you know, you need to take into account, you know, when you're doing your projects. Okay. Okay. And so, you know, advocates for this approach, for this capabilities approach, they really like this because it can be applied to, you know, all the many different consequences that can affect an individual. Okay. Okay. And so based on this, you know, we can come up with a another definition for acceptable risk from this capabilities kind of framework. Okay? But I'll write that down on the next page. Are there any questions on this page before I turn it? Okay. Okay, so according to the capabilities framework, a risk is acceptable a risk is acceptable if the probability is sufficiently small that an adverse effect will fall below a threshold of minimum level of capabilities that is acceptable. Okay. Let me write that down. Okay, so a little bit of a long definition, a little bit wordy, but basically, you know, what it basically is saying that is if, you know, the probability that, you know, the capabilities of a person is, you know, that their capabilities would be adversely affected, if that's sufficiently small, then that's, you know, an acceptable level of risk. Okay, and so of course, you know, this definition is vague on purpose, right? Because we use the terms here sufficiently small. And so that can mean a many different number of things. So you can have, like, you know, 10% that might be small. You can have 1% that might be sufficiently small. But it really depends on, you know, the types of fields that you work on. So, you know, one point of reference that you can make, you know, because especially, you know, if you're working in a field that's already pretty established, is that you can look at this kind of threshold, or you can look at the probabilities of, you know, similar projects and how they affect other people's capabilities. And if your risk is in that same ballpark, you know, for that kind of field, then, you know, you can define that as kind of an acceptable level of risk. Okay. And so, you know, unfortunately, you know, we can only just kind of breeze through this this kind of framework, but, you know, it's a good one to kind of think about when you're thinking about risk. So it's not only, you know, when you're designing your products, it's best to not only think about, is this going to kill someone or not, or, you know, is this person going to, you know, lose a lot of money or not, you know, how does it affect kind of their daily lives? So, and not only kind of physical things, but also, you know, mental capabilities emotional capabilities as well. So, all these things are really, really important to think about. Okay. And so those are kind of two different ways that you can define, acceptable risk, right? And I would say those are kind of, engineering ways to define that. Okay. But as you'll find out when you go into the workplace, there's a lot more than just engineering minds that influence a project. Okay? And so a lot of times the public and a lot of times your government regulators, they're going to have some influence on how you design your product. And a lot of their perspective and a lot of their input is based on their perception of risk. Okay? So let's talk about that a little bit. So let's first talk about how the public approaches risk in engineering projects. Okay. And so it used to be that, when you're talking about the public's approach to risk, that's mostly just the public that's going to be using your device. But now with, the way that the world works, you also have to consider, people that don't use your products and how they perceive your products and the risk and what they can kind of say about it on like social media and stuff like that. So, it's gotten a lot more complicated for sure. Okay. Okay. And so, specifically what we're talking about here is public perception, because, what we deem as maybe an acceptable risk from an engineering point of view might be labeled as really risky by the public. Okay? So there's often going to be this mismatch. Okay. And so there might be some activities or some products that, the engineer might think that, there's not that much risk involved in using this, but the public might see it as really risky. And then on the other side, there's some things where the engineer might, say this is really dangerous or really risky, but then the public might not see it as that big a deal. Okay. And so why is there this disconnect? So the disconnect comes from the fact that, the public is often, they either don't have the technical information or they're just kind of misinformed about the risks associated with certain technologies. Okay. And so, it's, in kind of the world of social media and misinformation, it might seem like, a really bad thing, and it is, but, it's understandable when you kind of think about it from the perspective that, the majority of the public, they don't go through the same kind of classes, the same kind of training that, we as engineers do. And so they don't have the technical knowledge in order to make these kind of informed decisions. Okay. And so, and specifically, I want to talk about a specific phenomenon called anchoring. Okay. And so what anchoring means is that, people tend to latch on to an initial estimate of risk and believe it. Okay. Okay. And no matter how wrong it may be, or even when presented with evidence that refutes this belief, people will still tend to side with their kind of initial kind of gut reaction to something. Okay. Okay. And so one example of this is that I can kind of talk about for my own life is that for my entire life I've always had a fear of roller coasters, and so this comes from just a fact from a situation that happened when I was little. And so when I was little, I went on a roller coaster at Knott's Berry Farm called I think it's called Boomerang or something like that. So it's like a blue roller coaster. It goes up and goes lots of twists and turns. And so I got really sick when I ran on Boomerang with my friends. So I think I was like maybe like 12 years old or something like that. And I could basically ruin the rest of my day. So I was like throwing up and like feeling sick. I didn't want to eat anything. And then since then, I basically decided that I don't like roller coasters at all. So even roller coasters that are really tame, it still kind of scares me a little bit, just because now it's even more expensive to go to like Disneyland or something like that. And I'm like, I didn't pay like $98 to come to Disneyland just to be sick all day. So, which is kind of difficult because my girlfriend loves roller coasters. So, she'll want to go on, a bunch of different coasters all the time. And I'm like, okay, I'll hold your purse and I'll wait out here for you. And I think it's even like affected my self-conscious, because it's like sometimes I remember one time I went on I guess it used to be called California Screaming, but I guess it's Incredibles theme now. And like it has that one loop, and like even though I feel like I've grown a lot since then, going through that one loop still made me sick for a while, although that one only lasted for about an hour. So anchoring can be a really powerful thing, so don't underestimate when people kind of latch on to, like, especially something that's really emotional or really affects them a lot. People tend to latch on to that, and it's hard for them to kind of let go of that. And what that means for us as engineers is that if you introduce kind of a new technology or a new product, and it has a very bad kind of initial reception or initial thing, like maybe something bad happens or something like that, then that will stick to people, and that will people will remember that for a long time, and it's going to take a really long time for them to kind of let go of that belief, right? And so that's definitely one thing to keep in mind when you're introducing these two things. Okay. Okay. Are there any questions on this? Okay. All right. So one other important thing to think about when you're talking about the public is that they often don't separate the concepts of risk and acceptable risk. So for the public, they're basically the same thing. Okay. Right. And so we as engineers, we know that when you use technology or you use certain devices, there's always going to be some risk, and you just kind of have to accept it, as part of your of using it, right? You jump into a car, there's going to be a certain risk associated with that. No matter how good the engineers are at Ford or or Honda or whatever, they can't eliminate all the risk with driving a car. But it's something that you just accept, as taking advantage of the convenience of having a car. Okay. And I think implicitly a lot of the public they know this too, or like otherwise no one would ever drive. But if it's something that's kind of new or unknown to them, right? Right. And so if the technology is new or unknown, any risk, and no matter how small it can be, will be seen pretty negatively by the public. Okay. Okay. And so even if you've done your due diligence, like you've run all the tests and you've run all the simulations and you've defined this as an acceptable risk, if there is a risk, then that's going to be viewed very negatively from the public. Okay? So oftentimes when you're discussing these kinds of acceptable risks to the public, you have to be really careful about how you communicate that. And we'll talk a bit more about communication later in the lecture today. Okay. Okay. So one way to kind of manage public perception of engineering technology is to obtain free and informed consent. Okay. And so just like as we saw from the lecture last time, if a person is properly informed of the associated risks and they, volunteer to accept them, then, then the perceived risk will be lower. Okay. And so, in order to obtain this consent in kind of an ethical way, you have to kind of be careful about how you obtain it, because you can't coerce the person. They have to be properly informed, which can be difficult because, it's sometimes, informing them of the risks, goes into a lot of technical details and, terms like that. You have to be careful about using that. Okay. And they also have to be rational and competent enough to evaluate that information. Okay. And so that goes for any type of consent, not only just for engineering, but you'll have to make sure that you do it kind of properly in order for it to really count. Okay. And one other wrinkle to think about is that when you do ask certain groups of people to assume some risks for using engineering technology, then ideally that group should be the ones that benefit as well. Okay. Right. And so, and this is really relevant. I wrote these lecture notes last year, but they're very relevant today. And so, it's not really fair to, expose maybe your essential workers to health risks, so that other people can benefit from their work, right? And so you have to make sure that, if you are asking people to expose themselves to certain risks with using engineering technology, a lot of times, from an engineering point of view, this often is like, the people that work in construction, that build like your airplanes, stuff like that, or the people that maintain the bridges or the buildings, right? And so asking people to do this kind of engineering work, with that comes with a lot of risks, right? And so you have to make sure that, when you're compensating people for these risks, that they're well compensated for not only their time, but also just for the risks to their own health, for the company, right? And so remember, these risks are not avoidable, right? And so whenever you are building like a big building or something like that, you're building an aircraft, there's going to be some risks associated with its construction. And so, it's impossible to eliminate all those things. But when you do ask people to take those risks for you, you have to make sure that they're properly compensated. Okay. Okay. And so, kind of summing all this up, we can come up with another criterion for acceptable risk that takes the public perspective into account. Okay? And so we can say that an acceptable risk is one in which the risk is assumed by free and informed consent. Okay. In which the people that are assuming the risks are properly compensated. Okay. And in which the risk is justly distributed. And so if you can satisfy, all these requirements, then, you have a much better chance of the public, accepting your levels of risk. Okay. Okay. Any questions on this? Okay. Okay. And so the next topic that we'll go over is the government regulators' approach to risk. And so in addition to the public, the government will have a big impact on, the direction of your engineering projects, okay? And the main way that this happens is that government, they often impose laws in order to protect the health and safety and capabilities of their citizens, right? And so, that's kind of the role that the government plays in this, okay? And so how the government views the risk for your engineering projects is, is a really important factor to consider, as you design your products. Okay. And so, if we kind of, put on the hat of the government regulator, there's kind of two different approaches or two different mindsets they can take to risk management. Okay. And so the first approach that they can take is what I call like a wait and see approach. Okay. And so what I mean by this is to basically, before you pass any laws or any regulation on a certain kind of technology, you can kind of wait and see how it acts in the public or how it affects people. Okay. Because for the government regulations point of view, there's new products and new technologies that come up basically on an hourly basis, right? And so maybe a company develops a new product, or there's a new type of way to get cell phone signal, or a new type of Wi-Fi, right? And so there's new technology that's occurring basically all the time. Okay? And so one way that the government can kind of act on this is they can let this product go to market, just to let the company do what they can. And then just kind of wait and see, how that product or how the new technology affects the public before taking action. Okay. And so why would the government take this approach? So there's kind of pros and cons for this. So the pros of this was that there's no wasted legislation or no wasted government tax money taken on precautionary measures that aren't needed. Okay? But the downsides of this is that if you wait and see for something bad to happen, then a lot of times it's too late. Then bad things already happened. Okay? And so with this approach, the public is kind of exposed to kind of larger levels of risk and consequence that are associated with new technologies. Okay? And so that's one approach. And so the other approach that they can take is a more proactive approach. Okay? And in the proactive approach, basically what the government's going to do is that it's going to pass laws and regulation to basically regulate every possible risk that could happen. Okay? And so the benefits of this approach is that it would reduce the amount of risk to the public, because a lot of times you can kind of get ahead of certain technologies and kind of put rules and regulations on them before bad things can happen. Okay? But this comes at the cost of lots of time and lots of money that's taken to run the tests and create and write the laws to regulate this stuff. Okay? And other kind of opponents for this kind of approach would say that this would also kind of stifle new innovations and new technology, just because companies would be kind of disincentivized to develop new technology if they know that there might be an uncertain level of regulation and fee that they might have to pay in order to bring it to market. Okay, so these are kind of the two approaches that can be taken, and so generally what's taken more is actually this one, the proactive approach. Okay, and so a lot of times government sees it as their kinds of job as their job to protect the public as much as possible. Okay. And so what regulators tend to do is that they want to avoid as many false negatives as possible. Okay. And so a false negative basically is basically something that, regulators and engineers, they say, okay, this is safe, you can use it, but it turns out to be false, right? And so false negative means that it's, something that's perceived to be safe, but it's actually harmful. Okay. And so from a government's point of view, they want to avoid these as much as possible, because any amount of harm that was not accounted for that goes to the public, that's often a really bad thing, because governments affect so many people. Okay.
What are false negatives again?
Yeah, so false negatives, they're situations where engineers and regulators they test a product and they say this is safe to use, so this is okay to release to the public. But then maybe a week later or 2 weeks later or months later they find out, oops, this was actually really dangerous and it produces a lot of risks. And so the negative comes from the fact that a negative test means that it's because you're testing for the risk, right? And so a negative test means that this is not risky. And so a false negative means that something is perceived to be safer than it actually is, right? And so you don't want that situation. So governments often want to, they're okay more with what's called false positives. And so false positives are situations where the regulators might say this is really dangerous, but in fact it's actually safer than that. So that's actually a more preferable situation, because in that situation you're exposing less people to risk and you're exposing less people to harm. Okay? And so what tends to happen more is that there are more false positives that come out of government regulation, but that's a more desirable outcome than false negatives. Okay?
Thank you.
Yep. Mm-hmm. Okay. And so with that, we can come up with one more definition of acceptable risk from the government regulator's point of view. All right, so from the government regulator's point of view, a risk that is acceptable is one in which protecting the public from harm has been weighted more heavily than benefiting the public. So another way that you can say this is that government regulators tend to be very risk adverse, right? And so they try to avoid risk, or they try to, exposing the public to risks as much as possible. Sometimes a little bit too much so, sometimes, aggressively so, but they'd rather, aggressively protect people from risk and, find out that later it wasn't that bad rather than the opposite situation. Okay, and so with that, I want to do another activity, and so this activity will probably take us until the end of class today, and so it's a bit long. And so what I've uploaded to Canvas is a case study. So if you go to the our week 12, so the class page for week 12, what you should see is I've uploaded a PDF there called Case Study for the Teton Dam. Okay, so everyone can go to Canvas right now and download that. I'm going to write down kind of your discussion questions, that you're going to look at. Okay, so I'm gonna put you into groups. I'm gonna use the breakout rooms and Zoom again, and I want you to read this case study and then answer the following questions. Okay, and so the first question is that what you're gonna find out is that this was a dam where there was a lot of fractured rocks in the canyon walls where the dam was built. Okay. And so the first question I want you to answer is, what precautions did the engineers take to lower this to an acceptable level? Okay.
Is this our homework assignment?
No, this is just going to be an in-class assignment. So it's going to be it's a different case study from the one that's on the homework, but it's just something we're going to do in class.
Okay, do you know where I can find the file specifically?
Yeah. Actually, let me share my screen. And so if you go to our home page, right, and then you go to week 12, and then it's this one right here, case study Teton Dam. Okay? And then after you download that, if you download the lecture notes from this week, which is the second one right here, dealing with risk and safety risk in engineering, you'll see the 4 discussion questions that I have for you here. So it's going to be on page 5 of those lecture notes, and these are the 4 questions. Okay? And so the first question was, what precautions did the engineers take to lower the risk? Okay? So the second question is, I want you to describe, the public risks that were associated with the dam. And so, when they constructed this dam, they knew that this was going to have some kind of adverse effect or adverse risk on the public, around that dam. Okay? And so I want you to answer, were the individuals that were at risk, were they properly compensated? And were these risks deemed acceptable from the public's point of view? Okay. Number 3, I want you to answer, how do you think the government regulators reacted to the failure of the Teton Dam? So, eventually this dam is going to fail. And so, spoilers, but that's what's going to happen. And so, when government regulators saw this, how do you think that they reacted, given, how they usually treat risk in engineering projects? Okay? And then after that, I want you to think about what kinds of regulations could they have passed beforehand to ensure a disaster like this doesn't happen again in the future. Okay? And then finally, the last question I want you to consider is, what precautions can the company make to basically make sure that failures like these don't happen ever again? Okay, so if you want, you can write down these questions and then download the PDF for the failure of the Teton Dam. And so it's a fair amount of reading, so I think it's going to take you guys a few minutes to read it. But it's an interesting read, so you can go ahead and download the PDF and read it. And once you're done with the reading, then you can discuss these questions with your group. Okay. So is everyone clear on the activity going forward before I split you guys up into breakout rooms? Does anyone have any questions? I think that's easier because I can't see your. If you're nodding right now, I can't see you because it's Zoom. Okay. So go ahead and download. Make sure you download at least the case study report, and make sure you download the lecture notes so that you have a copy of these questions too. And then I'm going to split you guys up into groups right now so that you guys can discuss. Okay? And so I'm going to split you guys up into groups of 4. And so I think we'll do well, maybe 3 or 4. So I'll do 9. I'll do 9 different rooms, and then we'll go from there. And so I'll pop into the rooms every now and then just to see how the discussion is going. So just to kind of help you guys out. Okay. Yeah, sorry, I didn't realize you were in a room by yourself.
No, I think my team just ditched me or something.
Oh shoot. Oh, did people go around?
I don't know where they went.
Oh
They
man.
just kind of left.
Oh, I'm sorry about
Yeah.
that. I'll chat with you. How about that?
Okay, well, I was still like reading it, so I thought they were reading it, but then they just left. So
Okay. Okay. Well, yeah. Go ahead and take your time and read it. I know it's a long read, so just go ahead and let me know when you're done.
okay, I think I'm just about done reading it.
Okay. Yeah. So, what do you even before the questions that I asked? What do you think of this this case study?
I don't know if this company's built over 250 of the same type of dam, but they didn't like consider the surrounding area, I guess. It
Mhm.
seems like a pretty big oversight.
Yeah. Yeah. It could be one of those cases where you know it's something that they've done so many times that they kind of overlook some of the risks that were involved because yeah, they might have built over 300 dams or so many of these, but then every dam is different because it depends on kind of the geography and the topography of the place that you're building in. So it could have been something that they either didn't put their best engineers on the job, or they just kind of got complacent with how they do things, that they didn't take into account a lot of these things. So yeah.
Do you know where this dam was located?
It was in
I think
Idaho.
it says.
Yeah,
Oh,
so I'm not exactly sure in Idaho, but it's somewhere up there. And a lot of the dams are actually kind of up there because there's a lot more kind of rivers and basins up there.
mm,
Okay. So from the reading, we saw that the engineers at least were somewhat aware of the risks, right? So they knew that the rock was very fractured, and kind of the quality of the rock wasn't the greatest. So they did do some things to kind of account for this. And so I think from the reading, they kind of dug some trenches near the top, and they kind of tried their best to force fill all the cracks with grout. Looks like
yeah.
so they knew that a bunch of cracks. They just try to drill some holes and fill it in, but um, that wasn't enough for that. And so they did try to do something, but I think when was this was back in 1976. So I think back then the tools for like assessing risk and accounting for that it just wasn't as developed as it was today. So I think it might have been one thing where like this is something that they've done in the past to kind of prevent these kinds of things from happening, but it just wasn't enough in this case because it was such a unique case. So what about the public risks? So what kind of risks were there to the public in the construction for this dam?
So, well, I guess there was people living along the dam because it flooded the river at
Mhm.
least and killed 14 people.
Mhm.
So, if they knew there was like a risk, I don't think it's acceptable for since it's like so close to the public for it to just be like the grout will save all these leaks.
Mhm. Yeah, no, definitely. Yeah, it's yeah. There of course, yeah. There's the people that are living nearby. They're going to be at risk because yeah, if something happens, then they're going to be the ones that suffer from it. Yeah, definitely agree with that.
They said the
Um,
gravel didn't end up carrying the water away like they wanted to.
yep, yeah, yeah, yeah. Whenever you have a loss of life from an engineering project too, that's always kind of a really big deal. Yeah, 14 is very high for something like this. But yeah, it's good. It's good. So do you think I know I don't think the article went into it, but like, what do you think that the company should have done to compensate these people that were negatively affected by this?
Hmm. Uh, Probably some form of relocation, maybe,
Mhm.
just in case something like this happens again. I mean, they probably lost a lot from from this much water just coming downstream. So it'd be kind of hard and kind of scary to live near dam again, I would
Yeah,
think,
yeah, no, definitely. Yeah, it's yeah,
especially now.
I think you're right. Yeah, definitely. Like relocation efforts or something to put them in a less risky position. I think that would be kind of the ethical thing to do for these people because they are assuming such a big risk. Um, by living next to such a big kind of construction thing like that, because if something happens, then there's nothing that they can really do about it. Okay. And so if you were a government regulator and you were kind of responsible for regulating dams, and you saw this kind of happen in the news or this report lands on your desk, how do you think you would react to something like this?
Uh, I mean, the company seemed like pretty, I guess, popular, I assume, and I think they should definitely like compensate the people that were affected by this. I don't know if they ended up doing that or they were in some lawsuit or not, but definitely should be like released to the public. Should just be like a one-off thing,
Yeah,
even though it was, but it's still important.
yeah, no, definitely. I think, yeah, definitely there should be laws written, yeah, not only on preventing these from occurring, but if they do occur, what things would hold a company accountable for these kinds of failures. So, like you said, like making sure that the families and all the people are properly compensated. And so if you're the company, so hi Sean. So I noticed you weren't assigned to a group, so we're just discussing. So do you know the activity that we're doing right now?
Yeah, so I was in the group room number 8.
Okay.
I got a call and then I jump into this group.
Okay. Okay. Yeah. So we're on the last question right now. So if you were the company, if you were the board of reclamations, basically, what do you think you can do in the future to basically prevent disasters like this from happening again?
Yeah. I don't know. So for better design.
Or I guess from a risk point of view, what do you think there are some things that they can do to like reduce the risk or get things to like an acceptable level of risk, or even just like communicate this risk better to the public?
So your voice is cutting in and out. Could you tell me that again, please?
Oh, okay, okay. Ajay, could you hear me? Okay.
Oh yeah, I can hear you.
Yeah.
Okay. Yeah. So what do you so what are things that you think the company could do in the future to kind of lower the risk and prevent these kinds of failures?
Are we both answering this? Or...
Yeah, or just either one of you.
Yeah, I mean that's uh they make it seem like this is definitely a one-off situation, so it's kind of hard to adjust from there to prevent something like this from happening. Maybe like just closer inspection, like some kind of soil analysis, maybe of like the area in the future.
Yeah, I think all those are great options. Just just doing as many tests and taking into account all the precautions as much as possible. Okay, so I'm gonna go back into the main room, maybe check on a couple other groups, but it's good. Yeah, I'm glad you guys read the articles and were able to glean something from it. So I'll see you back in the main room in maybe like a minute or two.
Okay, thanks.
Yeah.
Thanks.
All right, welcome back, everybody. A couple more minutes. Okay. All right. Looks like everyone's coming back into the room. So thank you everybody for participating in that. I know these kinds of group activities, group discussions in the Zoom setting are a little bit difficult. So I am hoping to hope that the discussions are still valuable and still good, because it's definitely a different feeling than having in the class. And so this activity, we'll kind of give you a little bit of a preview of what we're going to do from here on out, because I really want to expose you guys to a lot of these case studies, because kind of with the limited time that we have to talk about ethics, I think one really kind of effective way to kind of get these points across is to kind of study some things that have happened in the past regarding engineering ethics. So that's kind of the idea behind your final project, and then we'll also discuss some in the class as well. So this is kind of one of those case studies that we're going to go over. So there's no homework associated with this. This it's just an activity in class, but just to kind of give you a sense that even if it's maybe you might not have heard of the Teton Dam before, but you can see that there's a lot of examples of things that are disasters that can happen in engineering projects. Okay? And so first, I want this to kind of be open. So you don't have to. You can kind of just turn on your mic and say stuff, or you can type in the chat. Whatever you feel most comfortable with. So before we jump into the questions, just what is everyone's kind of first reaction when kind of reading the full case study about the Teton Dam? What were kind of the thoughts that were coming to your mind first? Yeah, that's one way. One reaction. Yeah. Anybody else? What were your thoughts about reading what happened to the Teton Dam?
I was just kind of surprised how they said that there was a 4-foot crack, but that wasn't enough to cancel the project. So that was surprising. That's a pretty huge crack. Yeah,
no, definitely. I definitely agree with that. With the no matter what kind of thing that you're doing, a crack that's 4 foot wide that someone can just walk right through, that's a huge red flag. I agree with that.
Oh, sorry, Professor. Why do they continue with that? I feel like you don't really got to be an engineer to know that that's not okay.
Yeah, no, that's a great question too. So it's a lot of these things, as you kind of read a lot of these case studies, that it's there's, especially a project this big, there's often a really big team of engineers, and not only engineers but also management, and also a lot of business people and financial people. A lot of people are involved in these projects. So a lot of times information like this that an engineer might see, sometimes that doesn't reach up all the way to the chain of command. So there's because people are not only designing products to be safe, but they're also for their jobs too. So it could be I don't know the specifics for this project, but it could be something that the head engineer or like the head manager was not made aware of this until it was kind of too late for that project. Yeah, definitely, I agree. It was very irresponsible for them to do so. Yeah. Okay, so we only have a minute left, so let's just talk about kind of the kind of one big question. And so let's talk about question 3. So if you were the government regulators, and you saw this happen, either on the news or like someone dropped this on your desk, what would be your first reaction, and what kinds of laws or what kinds of regulations do you think you can put in place to kind of prevent a disaster like this from happening in the future?
Maybe depending on the severity of the circumstances, they should place more safety precautions. Like in this example, they did that. They filled a trench with grout and slit. Maybe they need extra precautions other than that one example.
Yeah, no, definitely. I think there's no shortage of precautions. I think at the end of the article they were talking about, there just weren't enough like monitoring devices that are out there too. I mean, the 4-foot crack is an obvious, but I think if they had more monitoring for the for like the quality of the rock wall, and probably better communication in their company to kind of communicate these kinds of issues and have them be dealt with kind of in a timely manner, I think would help as well. So like creating rules and more checks and stuff like that is something that a government regulator, that's something that they have in their power to do. Yeah. Okay. Okay, so that's all we got time for today. So thank you everybody for coming. I know it's the day after the holiday, so it's it's kind of near Thanksgiving. So for the 26 of you guys that came out, I definitely appreciate it. And so we're going to continue with this next week. So next week we're going to talk more about health, risk and safety, particular about communications, how this stuff is communicated to the public. Okay. So I hope everyone has a great weekend. Remember the writing assignment that's due next Sunday. So make sure you guys are working on that. And if you have any questions on that, definitely reach out to me. And I'll see you guys next week. Thanks, guys. Do you guys have any more questions? Okay. So there's no more questions. I'm going to close the call. So have a good weekend, everybody.